If f of x equals to x to the fourth minus 4x cubed plus 4x squared minus 1, then the x-coordinate of all the points whose tangent line is parallel to the x-axis is a, 1 and 2, b, 0, -1, and -2, c, -1 and 2, d, 0, or e, 0, 1, and 2. To find where f of x's tangent line is parallel to the x-axis, you would first have to find where the tangent line is equal to 0, making it parallel to the x-axis. To do this, you would first have to take the derivative of f of x, which should give you 4x cubed minus 12x squared plus 8x. After simplification, you should be able to derive the derivative of f of x to be equal to 4x times x minus 2 times x minus 1. You would then take the derivative and set it equal to 0 to see when the derivative is equal to 0. And after solving, you should be able to get that when x is equal to 0, x is equal to 2, and x is equal to 1, that is when the slope of f of x is equal to 0. Therefore, when x equals to 0, 1, and 2, the tangent line is parallel to the x-axis, leading our answer to be equal to be E. The next question asks us to find the linear approximation for f of x equals to tan of x when near x equals power 4. To do this, you would have to use the linear approximation formula, which is the derivative of f of a times x minus a plus f of a. A in this case would equal to power 4 since we're using power 4 as the reference point. And the derivative of f of x is equal to secant squared x. After you plug a into this equation, you should get L of power 4 equal to secant squared power 4 times x minus power 4 plus tangent of power 4. Secant squared is equal to 2, while tangent of power 4 is equal to 1. So after simplifying, you should get 2 times x minus power 4 plus 1 as your linear approximation, the best linear approximation formula for this equation, which is answer choice D. 1 plus 2 times x minus power 4.